AWS is by far the most popular deployment platform, so in this video we're going to show you how to build a Flask REST API using Flask-Smorest, run it using Docker, and then deploy it to AWS using ECS and Fargate. Because I'm no AWS expert, for this video we've partnered with Arno from Cloud with Django, who's going to guide us through deploying to AWS. So this video is divided into two parts. First, I will guide you through building a REST API using Flask and Flask-Smorest, and then in the second part of this video, Arno will take what we build and will show you how to set up AWS to deploy it. And that includes setting up your AWS account, IAM users, how to push your containers to ECR, and how to run everything using ECS and Fargate. So it's a very comprehensive video, and I'm sure you will enjoy it. If you have any questions as we go along, make sure to put them down in the comments below, and hit like and subscribe for more tutorials like this. Oh, and let us know if you want us to do more collaborations like this one. Let's get into the video. Let's initialize our Python project using uv init and then --app. That gives us a few starter files. Let's delete hello.py and then create a folder which I'm going to call app, and in here create another folder called resources, and also within app let's create a few files: dunder-init.py, db.py, and schemas.py. Notice that these four things are inside app. Inside resources, we're going to create dunder-init.py and also recipe.py. Now we can close all these tabs as we will be opening them as we go along. To bring in dependencies into this project, we'll do uv add flask. That is going to create a virtual environment, and we should select it in Visual Studio Code. So just press yes in this dialog here. If the dialog doesn't appear, you can always press Command-Shift-P and then Python select interpreter and then find the virtual environment that's in the local path. To run the Flask app at any point, we can do uv run flask run, but we don't have a Flask app yet, so this won't actually do anything. Let's create a Flask app. Go over to app and then init.py, not the init inside resources. And here we'll do from Flask, import Flask. App is Flask and then dunder name. And we'll define an endpoint, which we'll call home, and that returns hello world. This is how you define a Flask endpoint. In this video, we're going to be creating a REST API using Flask-Smorest. So we're going to do things a little bit differently, but this will let us test whether this is all working. If you do uv run flask run, again, this will work because our folder is called app, and that is the default for Flask. If you wanted to customize where your Flask app is located, or you didn't want to call this folder app, you would create a file in the root of your project called .flaskenv, and here you can define an environment variable called flask_app, and in our case it's simply app. This is the default, and it goes into app dunder-init.py and finds the app variable within this file. Later on, we will change this. For now, we can quit by pressing Ctrl-C at the bottom. Let's add Flask-Smorest as a dependency as well. And now we'll create a Flask-Smorest API by doing from Flask-Smorest import API. Now we can delete this route and say API is API of app. And now we need to do API.registerBlueprint and pass in a blueprint which defines the various methods that we can use in this API. So let's define a blueprint that we're going to define inside resources. So let's go over to resources recipe.py to do that. We'll begin by doing from Flask-Smorest import blueprint, and then we'll define a blueprint which I'm going to call BLP, and we'll say blueprint, and now we give it a name, which is going to be recipe. We give it an import name, which I'm going to say is recipes, and then you can give it a description that will show up in the documentation, which for now we're going to keep simple: operations on recipes. Now we can say at blp.route and pass in what endpoint this blueprint will accept. Within this endpoint, we will then define what functions will run for the different HTTP methods, such as get or post. So we'll say /recipe /string recipe_id, and this is how we accept an argument in an endpoint. And now, funnily enough, what goes under this decorator is a class. So we'll say class recipe, and this inherits from the Flask method view, which we need to import. So let's go to the top and say from flask.views import method view. What is a method view? Well, in a method view, you've got various methods such as get or post. And now what will happen is that when a user sends a request that is a GET request to this endpoint, we're going to call and respond with whatever this function responds. And if they send a POST request to this endpoint, then we're going to run and respond with whatever this function responds. For each of these, we need to define with @blp.response what the default response status code is, and that's 200. And we also need to define the shape of the data that this is going to respond with. So if we respond with a dictionary, then that dictionary will be converted into whatever shape we define here. I'm going to say recipe schema, which we still need to code. So let's go over to schemas, and then we will code out the recipe schema. Flask-Smorest, which is the API library that we're using for Flask, uses Marshmallow to define its schemas. So we'll say from Marshmallow, import schema and fields, and now we'll define a recipe schema, which is the shape of data for a recipe. We can say class recipe schema inherits from schema, and then what fields are in here. We'll say ID is a fields string. We'll say name is also a string. We can say ingredients is a list of strings, and instructions is a string. But we're going to use this recipe schema to validate data that the user sends us when they want to create a recipe, as well as what data we send back when we have created a recipe or when we found a recipe to show the user. In one of those cases, we don't want to use the ID field. And that is when we are creating a recipe. Because the ID field is going to be auto-generated by our database, we don't want the user to have to send us an ID field when they want to create a recipe. So we will say dump only is true. And now this field will only be used and validated when we are responding with data and not when we are receiving data. For the name, we're going to say required is true to make sure that this is there both when the user sends us data as well as when we respond. And here we will say required is true as well in this list. And finally, for the instructions, we will say required is true as well. Now, users may be able to update a recipe that has a given ID field and change its name, ingredients, or instructions. So we need to create another schema that defines the shape of data that a user may be able to send us to update a recipe. I'm going to copy this recipe schema, paste it down here, remove the ID, and rename it to recipe update schema, and then remove these required equal trues so that the user can send us one of these or more when they want to update a recipe. Let's also code our database.py file while we're here. And you can use a database such as PostgreSQL or SQLite. For now, I'm going to use a Python dictionary, which will behave as an in-memory database. And we'll say that this file mimics a database for storing recipes, and recipes have a unique ID, name, ingredients, and instructions. Later on, if you wanted to swap this out for a SQL database, you could just create a table for your recipes with these 4 columns, and you'd be good to go. But for simplicity, we'll keep it as this for now. Alright, so what do we put inside our blueprint? First of all, let's import our schema. So we'll say from app.schemas import recipe schema, and we'll also import recipe update schema while we're here. And we'll say from app.db import recipes, which is our database table. Now let's first work on creating new recipes. First, what data will this function expect from the user? We can say blp.arguments and put recipe schema. In order to create a recipe, they need to send us data in the shape of a recipe schema, which contains a name, ingredients, and instructions. Remember that ID is dump only, so it's not required when we receive data. We'll also define what it's responding with. So we'll say response 201 and recipe schema. Now the post here will take self, as all methods do in Python, and also the recipe data that is coming from taking the user data, passing it through recipe schema for validation, and then we get it as a dictionary in here. Now let's generate an ID for the recipe. We'll say recipe ID is UUID 4.hex, and we need to import this. So let's go over to the top and say from UUID import UUID 4. This is going to generate a universally unique identifier with version 4. Now that we've got the recipe ID, we can join the recipe data, which contains the name, ingredients, and instructions, with the recipe ID to create our final recipe dictionary. So we'll say new recipe is, and then pass in recipe data and also the ID. This is how you can unpack a dictionary and then put it into another dictionary with extra values. Then we'll say recipes, recipe ID is new recipe. So what we're doing here is we're storing in the recipes dictionary, which is in our database, under the recipe ID key, the entire recipe dictionary. Doing so will let us search by recipe ID when we want to find a specific recipe. Finally, we'll return new recipe. Now notice I've made a small mistake here. The route that we've defined on the recipe is /recipe/recipe ID. but the post method does not accept a recipe ID. Also, when we create a recipe, we don't yet have the ID, so how would we receive it? We need to put this method to create a recipe inside a different class, which I'm going to call recipe list. This also inherits from method view, but the route is different. We'll just say /recipe. All right, now this is getting long. Let me close this terminal down here. And now that we have our recipes created, we can then get them. Here we'll take self and recipe ID, which is coming from here. Now that we have the recipe ID, we can search for it in our recipes dictionary and return it. So we'll say recipe equal recipes.get with recipe ID. And this can return none. So if not recipe, then we'll abort with a 404 and we'll say message recipe not found. Now abort is something that also comes from Flask-Smorest and will create a JSON response with this message. Otherwise, we will simply return recipe. And now this is going to get passed through the recipe schema and turned into JSON with that shape. So what if we wanted to update a recipe? We can define a put method that also takes in recipe data and recipe ID. And then we will update this recipe with this data. In order to do that, we need BLP arguments and accept the recipe update schema and @BLP response 200 and recipe schema. So now this will accept any of the 3 fields in recipe update schema or 2 or 3 fields and will respond with the updated recipe. To do that, we'll first get the recipe. We'll say recipes.get with recipe ID. And again, if recipe is not found, we will say that it's not found. Otherwise, because recipe is just a dictionary, we can say recipe update and pass in recipe data. This is how you update a dictionary in place, so it can be updated in our database. Finally, return recipe. What about deleting? Well, since this is a method view, we'll create a delete method that takes in the recipe ID. Here we'll decorate it with BLP response of 200 and a description of recipe deleted. Notice that we haven't put a schema here because this is not going to respond with any specific schema. You can always add a description to any of these BLP responses so that they will appear in the documentation. Now, all that we have to do here is again, grab the recipe, and you could extract this to a function since we're using it in 3 places. We found the recipe, so we'll say del recipes with recipe ID, and then we'll return a message. You can always return whatever dictionary you want and it will be turned into JSON. If you don't put a schema in the response, it won't be validated and converted into that shape, so you can put whatever you want. We'll say recipe deleted. All right, since we've got this recipe endpoint to create new recipes, let's also find a way to create a list of recipes. So we'll say get, and we'll return a list of recipes.values. This is how you can get all the values in a dictionary, and we're turning it into a list so that we can return it in JSON, and the BLP response will be 200 recipe schema. And now we can put here many equal true to tell Flask-Smorest that this is going to be a list of recipe schemas and not just one recipe schema. The last thing that we want to do is make sure to register this blueprint in our app. So let's go over to init.py, and here we'll say api.register blueprint, and we'll pass in the blueprint that we need to import, which is from app.resources.recipe import BLP as recipe blueprint. I always name my blueprints BLP within each resource file, and then I import it as different names, so here it's easy to see which one you are registering. Now there are some configuration settings that we want to set when working with Flask-Smorest, and those are here. The API title and API version to be shown in the documentation, and then open API version, URL prefix, Swagger UI path, and Swagger UI URL if you want to load Swagger UI for this project. Let me show you what that looks like. Let's bring back the console and type uv run flask run. And notice that it says there are .env or .flask-env files present. Do pip install python.env to use them. So let's actually quit this with Control-C and do uv add python-.env. There we go. Now we can do flask run again. Let's go over to 127.1.1:5000, and you can see that you get a 404 not found. That's because we're accessing /, but our API doesn't have this endpoint defined. It only has recipe or recipe/recipe ID. You can also go to /swagger-UI to open up the Swagger UI for this API. And here, if you go to post, you can try it out and create a recipe here. So we'll say name is a levain, ingredients is 100g flour, 100g water, and a pinch of yeast. And in the instructions, we'll just say mix it all together. Mix it all together and wait 24 hours. Now we can execute this, And you can see that we get that this has been created. We've got our auto-generated ID and our ingredients, instructions, and name. Now we can go up here to get recipe and try it out. And you can see we get a list of recipes. Let's grab this ID specifically and go to get recipe ID, try it out and put the recipe ID in there. We can hit execute to get just those recipe details. So what if you want to run this using Docker? Well, it's very easy. You can just create a Docker file. And here you would start with from, which is the image that you want to build from. So the base image for the Docker image that we are going to build. We can say Python 3.10. Of course, you can use a later Python version if you want. Then you would say expose 5000. This is just a piece of documentation that tells the user of this Docker file that this port is where you want to connect to. We'll say workdir/app. And now by far the easiest way to go about it is to get a requirements.txt file. So we can say copy requirements.txt to requirements.txt within app. What this does is get the requirements.txt inside your local directory, which we don't have one yet, and copy it into a file called requirements.txt inside the current working directory, which is /app. Then we do run pip install --no cache dir --upgrade -r requirements.txt in order to install the requirements that we've just copied in there. And then copy ... which will bring everything in the current directory into the current working directory of the image, which is /app. And finally, you'll need a command, which is what command will be executed when we start running this image as a container. We will say flask run --host 0000. To generate the requirements.txt file, we can just do uv pip compile pyproject.toml -o requirements.txt. And that is going to generate a comprehensive requirements.txt with everything that we've got installed at the moment. Notice that it locks the version numbers in there. Now, if you want to run this Docker file in production, there are a couple changes that we should make. The first one is that you'll probably want to expose port 80. That's just the default when working with HTTP. Since HTTP requests are usually made in port 80, it will make everything a little bit easier. And then instead of running with Flask Run, which is the development server for Flask, we want to use a production grade server such as GUnicorn. So we can say uv add GUnicorn, and then make sure to recompile your requirements file with uv pip compile pyproject.toml -o requirements.txt. And then here in the command, we will say GUnicorn -b 0000:80. And this is going to allow incoming connections to GUnicorn from any IP address on port 80, as long as we're connected to our Docker container. Finally, we need to pass it which Flask application we want to serve. And at the moment, that would be app:app. So this would go into app.init.py and find the app variable. But since we're in the topic of production mode, we should really serve this app using the factory pattern for Flask. So we'll say def create app, and then we can simply put everything inside here, and at the end, return app. Although we're not using it at the moment, this pattern is better for testing because we can create different apps and use them without having to re-import this file. And also we could potentially pass in different configuration settings for each app just with a single parameter. So this is a little bit better. And if you want to do this, we go to the Docker file and say create app here. And again, this goes into the app folder under init.py by default, and then calls the create app function to get the Flask app that you want to serve. All right, and with this, we are done building the Flask app. Now we're ready to deploy it to AWS. So let me pass you over to Arno from Cloud with Django, who's going to guide you through deploying this Docker image to AWS.
So what we want to do now is we want to go on ahead and we want to build our Docker image. Navigate to your terminal. I'm going to use git bash, and I'm already within the project directory. We can say docker build, so we want to build our image, and then we want to tag it, so we can say -t to tag that particular Docker image that we'll be creating, and we're going to call it Flask API -AWS space dot for context, and we can build our Docker image as follows. So as we can see now, our Docker image has successfully been built. And just to give you some clarity in terms of the steps and stages, so we can see here all of the instructions here situated in this Docker file, such as the step here to copy everything in our application directory, to install all of the various packages that we specified in the requirements.txt file. Okay, so we've got everything set up and ready to go. So now if we head on over to Docker Desktop, you'll now be able to see that we have our Docker image here situated within the local repository. Now, if you don't see it when you navigate here, sometimes you need to close and open up Docker Desktop again to see it. Right, so there we are. We now have our Docker image set for production. We need to now go on ahead and set up AWS. So I'm just going to give you some clarity on setting up AWS and also setting up the AWS CLI so that we can programmatically communicate with the various AWS services for managing our Docker image. So the next step is going to be focused on AWS. Now head on over to aws.amazon.com. And then you want to create an AWS account. Then you're going to sign up with your email. If you want to also choose a designated AWS account name. And as soon as you've done so and completed everything, we'll meet again in the dashboard of AWS, which you will eventually be redirected to. This is the AWS Management Dashboard. With your root account, you can immediately dive in and use all of AWS services without any restrictions or issues. However, it's a best practice to rather use an IAM user just so that you can manage which permissions are attached to that user. Your root account is really mainly just for account setup or making any key changes to your main account details and such. So we're going to make use of the IAM service. So you can type in IAM here in the search bar. And I'd recommend that you pin this to your navigation bar so you don't need to keep on searching for the same thing. And this service is going to allow us to manage access to AWS resources. So now we can click on IAM. Go on ahead and open up this info panel if it's closed here, and you want to click on users. So we want to create an IAM user that we're going to utilize. So we can say create user under this table. Then you want to follow the 3 steps here. So first we want to specify our user name. So I'm going to call this user chest user 1. We want to provide this user access to the AWS Management Console so they'll be able to sign in to AWS, so we can say yes, and we're going to want to create an IAM user, after which we want to choose a custom password and we can enter in a password that we want to utilize. We don't want users to create a new password at the next sign in, so just make sure that you have your own custom password. Once you've done that, you can say next. And then we want to set permissions. So this is what we want to allow our users to do. We can go ahead and do attach policies directly. So we can attach these permission policies directly to this user that we're creating. Usually you would add a user to a group and add policies to that group so everyone in the group inherits those permissions. But let's keep it simple and attach the policies directly to this sole user. Then you want to choose the permission policies. Now, we don't want to be restricted by anything, so we're just going to say, I want administrator access. So you can do so by clicking on the checkbox and it will be linked right here. Now, sometimes you're going to have to be more explicit on a service. So even though the administrator access permission policy gives you access to all the AWS services, there are certain policies that need to be specifically invoked. So when we are pushing our Docker image to AWS, we'll be using the ECR service. So the permission policy is known as Amazon EC2, which you can type in, Container Registry Full Access. So this is part of Amazon ECR. Okay. And we need this to ensure that we don't have issues with pushing Docker images to Amazon ECR. So make sure you have these 2 permission policies selected. Then you can scroll down and say next. Just make sure you review everything, and if there's anything that you need to change, you can go to the previous step or say cancel and start the process all over. Just make sure that you have the following permissions here in place. Next, you can create your user. And there you go, your user was created. We can also see here's the console sign in URL as well, followed by username and password. Okay, save this sign in URL. You can just even head on over and save it somewhere. Of course, your username as well. I would recommend you also just put that somewhere safe, and then your password too, which I'm just going to put a few stars there. So make sure that you save all this information. Then you can return to the users list, say continue, and then we can see this user is created. Now let's sign in with that user so we can use AWS effectively with the services. So you can click here on the top right hand side, and sign out of your root account. What you can do is you can go ahead and copy that URL, paste that in, press enter, and that's going to take you directly and filter in your account ID for you. So you need to add in your IAM username and your password now. So let's go ahead and do just that and then sign in. So you can now see here on the top right your IAM user account followed by your AWS account ID as well. So make sure that you're signed in as follows. Now, the next thing that we want to do is we want to install and set up the AWS CLI. So this is going to allow us to make programmatic commands to AWS itself. So here's the link that you'll need to set up the AWS CLI. And what you can do is you can scroll down and set it up according to your operating system. So if you're on Linux, macOS or Windows, you would choose the respective section, follow the details and install it the way that you prefer to install it. So if you are, for example, on Windows like me, you will click on Windows and you'll scroll down and install the AWS CLI version 2. It's going to download the CLI installer, which you can go ahead and click on. Welcome back. So as we can see, the AWS CLI has been installed. And now let's just confirm that we have the CLI installed on our machine. Open git bash, and I'm just going to say clear to clear all of this clutter. And you can just say AWS -- version. Let's enter, and there we go. Perfect. So we've got the CLI installed. Now we need to configure a set of access keys. Now what you can do is you can head on over to IAM. And you can create a set of access keys for your user to allow this communication to take place. So head on over to your list of users. You can click on test user 1, go to security credentials, and create an access key. Now, please make sure that you don't share your access key with anyone. It's very sensitive information. So we can say create access key. And here is a list of use cases. Our use case at this moment is an application running outside of AWS. We can just say next. We can say create access key. And here are our access keys. So I'd recommend you copy them and save them somewhere. So I'm going to save it here in this file that I had. So here is my access key and here's my secret access key. So I'll just copy the both. And there we have them, save that. You can also go ahead and download the .csv file, which will have these listed nicely for you as well. So now you can just say done, continue, and there we have our access key here that we're going to use. Now we want to configure our access keys with the AWS CLI. To do so, all you need to do is you need to head on over to Get again, and you can just say AWS configure. Then you want to enter in your access key ID. And then your access key details, you can also enter that in as well. So let's paste that in. And then the region here you can set. So mine is US East 2. Now for clarity, you can look in your dashboard and see which region you want to set. For continuity, I would recommend as your first time just setting it the same here. This isn't going to be a huge difference. So don't worry, you're still going to be able to deploy your application. And then you can leave the output format as none. So that's the first thing you need to do. You need to configure your access key and the region that you want to use. So now what we want to do is we want to look for the ECR service. So Amazon ECR is known as Elastic Container Registry. So it's a managed Docker container registry. So we can also pin that to a navigation bar. So here is where we are going to learn how we can store our Docker images. Okay, so this is what most of you will see for the first time. So we can say create a repository and give your repository a name here. And we can say create. And it's very easy to use this service. So there is our repository created, Flask repo. Click in that repository. And here is where we're going to push our Docker image to from Docker desktop right here. So we need to view the push commands. And you can see here there's an option for macOS and Linux and Windows. Now, since we are using git bash, you can still go ahead and use the macOS/Linux option here. So some people occasionally get a bit confused with this whole process, but Even on Windows, it's going to work perfectly fine. So for all of your devices, now usually this is going to fail if you didn't set the Amazon EC2 container full registry access permission policy, or if you, of course, haven't set up your AWS credentials properly. So your access key and secret access key, those are the most common reasons why it won't log you in. So just keep that in mind. Next, it's to build our Docker image, but we already have that, so we can skip to part 3 and 4. Now, with part 3 and 4, we need to tag our image so we can push the image to this repository. So everything here is correct. We're going to push this into the Flask-repo repository under the latest image. However, the tag here is incorrect. So we are using, in fact, as the tag, it's Flask API-AWS : latest as the tag here. So we just need to make that adjustment. So copy this here, head on over to your terminal, paste the following in, and you just want to use your arrow keys to go back to where it says Flask-repo latest. So instead, you want to look at the name that you have. So in our case, it's Flask API-AWS, and you can press enter. There we go. And that tag you're going to see here. So it's been tagged from AWS. Then you can head on back, and now you can just copy this command as is and push your Docker image straight to this repository here in AWS and Amazon ECR. You can right click and paste the following in and press enter. And that's going to push your Docker image for you. So it's going to take some time here. Right, so welcome back. So as we can see here, our Docker image was successfully pushed to Amazon ECR. So we can just minimize and close the steps as well. Now, if you refresh, you should see your latest Docker image here in place, appear as the image index. Now, of course, in many cases, you're just going to see one image here with a latest here. But in other cases, what can also happen is you can have sub-images part of your main image index, which is the one right here that says latest, and that's going to be the image that you're going to reference. So the next thing that we want to do is we want to look for the ECS service, and we want to tag that, and this is going to allow us to transform our Docker images to run as Docker containers. So you just want to pin that here to navigation bar and open that in a new link. So the first thing that we need to do is we need to create a task definition. So you can click here on your info panel, click on task definitions, and we want to create a new task definition. A task definition is a blueprint in Amazon ECS that defines how we can run a container. In other words, what Docker image to use, resources and settings, and all of that. To reference the task definition, you need to give it a family name of sorts. Okay, and that's going to be the name. You can give it any name that you desire. Then under infrastructure requirements, we're going to use it the simplest way. So we're going to use AWS Fargate, which means we don't need to manage any servers in the backend. AWS does that for us. So it's serverless computing for our containers. Right, everything we can leave here on the default. There's a lot of intricate and involved settings, but I'll keep it rather brief. So under task size, for our application, the current vCPU and memory is perfectly set. We can leave the task role and task execution role. So it's going to create all of that for us. Under container, we want to give our container a name here. So I'm going to say demo app container. And here's where you're going to specify and link your image URI. So if you go to ECR, you can see under latest for this image here, you want to copy that URI and you want to paste that in. So that's going to link this Docker image to this container. Then under the port here, we can see the container port is set, the TCP here, and of course you can also add in a port name if you want. I'm going to say demo app container -80-TCP, so that's just a name that you can assign your port name here, but make sure it's on port 80, which it should be by default, which we configured in our Docker file. You can add port mapping here, but we're just going to keep it rather simple. In the future, if you're building applications with sensitive data, here is where you can add in the key pair values of your environment variables, or you can just add an environment variable file as well. So we can scroll down, leave everything on the default and say create, and that's going to create our task definition. And that's going to be the definition of configuration settings for our tasks itself. So there we go, we've created our task definition, which assigned an ECS task execution role to allow us to execute various tasks. We can see some more information here in terms of CPU memory and the container and where the image is going to be connected from. Hey, great. So now we can go and create a cluster. So we can say create cluster. And this is essentially going to group a list of all of our tasks or services. So a task is a running instance of a container that is based on a task definition. And clusters house all of this together. So a weird thing with AWS is whenever you use Amazon ECS the first time and create a cluster the first time, it's going to fail. So I'm just going to give it the name of test cluster, and that's just kind of a bug in AWS naturally for your first time using it. And the reason is that the service role is only attached to you later on. So what we can do is keep the cluster as test cluster here. You can keep it on AWS Fargate, leave everything as is, say create. And it's going to have an error the first time. This is expected. So we can just delete this cluster in CloudFormation. So let's right click and open that. Now I know some of these topics are a little bit out of scope and a little bit complicated, but don't worry, I'll just explain the briefest parts here. So here is where we can see the stack for that cluster. And what you can do is you can just close this message here, and we can see here we have this failure. We can go to the stack. And we can just go ahead and delete this cluster that we have just created here. So it's selected here. You can just say delete and delete that cluster. And there it's gone. Okay. All right, so we can close that, create the cluster again, and let's give it the name again. We're going to say test cluster. Make sure it's AWS Fargate for serverless, create, and you're going to see it's going to work perfectly fine the second time around. And there we go, our cluster has been created. Let's refresh. And now what we can do is click on our cluster here, scroll down, and you want to create a task. So we're going to click on tasks and run a new task. Okay, and here we can see the environment is going to be within our test cluster. We're going to use the default capacitor provider strategy. So this is the launch strategy, which is the default with our task here. We're going to be utilizing Fargate using the latest platform. We want to use a task, and that task definition, which links details on the image that we want to use to run as a task. We can say select family. That definition was in my first task definition test. Use the latest one, which is version 1. We want to set up one task. Now we also have networking here in place. We want to clear our current selection and just select the subnets. That's just to ensure our application is going to be placed across all our availability zones in our region. Then you want to create a new security group. This is going to allow us to manage access to HTTP on port 80. So give it a name here. Let's set that as ECS-SG1. And then here for your inbound rules, you want access on HTTP. So you want to say HTTP port range on 80, that's the port we exposed. Here under the source, we can just say anywhere. So that's going to allow access from all IPv4 and IPv6 addresses on port 80. Right, so that's inbound rule. You can also create rules for SSH as well if you want to SSH into your application. But let's keep it simple for now. And there's a lot of things you can add in, but let's go ahead and create this task now. So this is the simplest way that we can go ahead and run our Docker container. So our task was launched. We can close that. And we can currently see it's in the pending state. And we can see here if we refresh, it's currently just being set up and run. So I've waited a few minutes, and you can of course refresh your cluster. And you can now see that we have one task running. We can see that this task here is in the running state. So now we can go ahead and actually access our application. So you can click here on your task, and you can scroll down until you see the public IP here. So what you can do is you can open this in an address. So you can right click and open that in a new tab. And then of course you'll be able to see your application here, right here at this address here. And as we can see, we connected to a public IP address. Now, if you want a domain name, so you're going to want to set up a load balancer. Now, this is a little bit further ahead in terms of the process and steps, but this is the simplest way that we can get our Docker image running on AWS. Right, guys. So that's it for deploying a Flask application onto AWS Fargate. Now, just to help you here to clean up your resources, you can go to your cluster here, go to tasks, just refresh, click on it, go to stop and say stop all. And we need to type in stop all tasks. There we go. And now you want to just refresh and you'll see that we don't have any tasks running. And now I'd recommend you delete your cluster. So delete cluster, type in delete and then the name of your cluster, and it's going to take a moment, so let's wait for that, but it's going to also delete the stack. So we can refresh, go back to clusters, and if you refresh you can see it's all gone now. All right, if you want to also delete your repository, you can go to repositories, click on your repository, and you can say delete. Let's say you can also clean up your resources if you desire to do so. Right guys, so that is it essentially in terms of deploying your Flask application to AWS by using Docker and Amazon ECS.
Well, that's the end of this video. Thank you so much for watching. We've gone through so much. We've learned a lot about Flask, Python, and AWS, and we've really sped through it. If you want to learn more about AWS, make sure to check out some of Cloud with Django's videos that are linked down in the description below. And we've also got a few of our own Flask development videos that I'll leave linked as well. Thanks for joining us in this video. Let us know if you want us to do more collabs like this one, and I'll see you in the next one.